Today's lecture is Chapter 6, Reinforced Earth. Let's just remember what we took before. We started with our introductions, types of foundations, and then we started studying shallow foundations, mainly isolated footings, and we studied isolated footings, whether subjected to normal force, moments, and so on. So by this we covered the important part in shallow foundations. Of course, we studied the chapter of bearing capacity and settlement because it is important for the design of isolated footings. Then we studied chapter 5, problematic soils. By this, we more or less ended up the interaction between the soil and the foundations in the shallow depths. Then we started studying the deep foundations. We took few lectures in deep foundations, how to design deep foundations. Then by the end of these lectures, we covered all what is related to the vertical loading of the soil, whether on shallow foundations, on deep foundations, different types of soil, everything related to the vertical loading. Then we started another direction. We wanted to study horizontal loading for soil. So we took a few lectures for retaining walls and lateral earth pressure. So this was the first thing that we studied concerning the horizontal loading of the soil. Then we studied shoring systems. This was chapter 7, retaining wall and lateral earth pressure. This was the first step to know what is lateral earth pressure and what are the different types of retaining walls. Then, chapter 8, we took a special type of lateral retaining system, which is the shoring systems. And we said the difference between shoring systems and retaining walls. Retaining walls are permanent, shoring systems are temporary. Retaining walls should be architecturally feasible, and we have most people can use it or deal with it easily, but shoring system may be used in during excavation, during construction, during any permanent job. So shoring system is a type of retaining wall, but it is the type that is used for temporary casing. Now we are going to study another thing, which is the reinforced earth. What is reinforced earth? From the name, it is earth, but it is reinforced, like the name concrete and reinforced concrete. Concrete is the plain concrete. Reinforced concrete is something stronger, carries more loads, more stresses, using additional reinforcement. So it is the same application. This is the normal shape of a reinforced earth. The idea in reinforced earth is that in normal walls, if I have a normal wall like this, a normal retaining wall, this retaining wall will be carrying everything behind it. Engineers thought of another thing. Why not use a mix between the facing of a retaining wall plus part of the soil and integrate them both as if they are one unit, so that they would act as a retaining wall. So in a reinforced earth wall, it is not only the face of the wall that is carrying the load, but the face of the wall plus portion of the soil behind it, using some kind of reinforcement that would penetrate through this mass of soil, so that they finally would act as one piece. So this whole system will be my reinforced earth. So it is a very good idea. Why not? Because I'm using the soil, the soil that is in place, or even if I import it from outside, it is still very cheap concerning to anything, any construction. And I'm just using a facing, a concrete facing, or maybe it may be made of any other material, just a simple facing, plus these lines. These are the reinforcing systems that are included to make the facing and the mass of this soil work as one piece. Anything beyond this mass will be carried by the wall. So this will be my wall here, this here, this is my wall. But here, this is the load carried by the wall. Anything beyond my wall will be resisted by the wall. If I need bigger wall, what I'm going to do, I'm going to increase the width. I'm just going to add to the wall a portion like this. If I add a portion like this, then my wall will be more stable, and so on. So this is what a reinforced earth system look like. For the facing is just pieces. It may be pieces of concrete, it may be pieces of special type of plastics, it may be pieces of any material that is strong enough just to carry a small portion of load. This facing now is not required to carry all of this load, it is just required to carry small portion, very small portion of load that is just behind it. So these are the pieces. These are the pieces of the facing in an elevation. Each piece is connected to a reinforced line. So this is a reinforcing strip. This reinforcing strip is connected to this facing, and it keeps it in place by the friction between the strip and the soil, and it ends up with this facing. So finally, instead of having a big wall, I'm just having a facing connected to a strip, and this strip, using friction, it adheres to the soil around it, so I end up with having of all of this bulk as my reinforced earth. So actually it is a very, very good idea. What we need to know is SY. SY is the spacing, the horizontal spacing between the facing. If this is one facing, if this is the center of the facing, and this is the center of the facing, so SY is the distance between the centers of the facing, and actually the center is the point of connection of the reinforcing strips. So behind this point I have a strip, horizontal strip. Behind this point I have another horizontal strip, and so on for all points. This is just a photo to tell you what huge can this system be. These are people, and this is a wall. Imagine the height of the wall. If this is, say, 3 meters, then this may be 12 meters or more. So a wall of height of 12 meters, and it is very cheap. Why? Because it's just made of facing and few strips, and I'm using the soil to be my wall. If I use a similar reinforced concrete wall, it will be a huge construction and it will cost a lot. So this is just for the information. For history, this idea was the idea invented by a French architect called Henry Vidal in 1963. Yes, 1963. So it is very old idea, but the application recently became very well known. So the idea is known from very long time, but the application started to be a lot now, maybe in the last 2 decades. How to do this? Henry was trying to build a sand castle. He was on the seashore and he was trying to build a sand castle. Yet it kept falling off, as the sand was not a supporting factor. Hence, he produced the idea of reinforcing the construction with pine needles. This is pine needles. He got these pine needles, he added inside the soil, whatever he constructed, and finally, imagine that these are the soil particles, and I'm adding the pine needles in between. So what happened? He managed to build the sand castle very easily. And this is how the general principle of reinforced earth came about. The principle of sand pie reinforced by pine needles is applied. This is a sand pie, and these are the pine needles. He just inserted the pine needles inside, and he managed to construct the castle that he wanted to do. So the idea came to him. Why not reinforcing the soil to be a wall? Instead of putting a wall next to the soil, reinforce the soil itself, so the part that is reinforced will act as a wall, and use the part that you need. Increase it as much as you want, so this would be adequate as a retaining wall. This is another shape of the wall. These are all facing the parts of the facing. Facing are just simple. Don't imagine that they are retaining walls. They may be something like 10 centimeters to 15 centimeters, something very, very trivial, corresponding to a similar retaining wall that would be maybe 1 meter thick to carry a considerable height. What are the benefits of a reinforced soil or reinforced earth? By the way, reinforced earth or reinforced soil are the same, but one of them is a trademark and it is registered as the name of a company. That's why we use the other. Wire mesh / geotextile fabric construction material are light. Here, instead of these pine needles or these here, these reinforcing strips, they are called these names. They are either wire mesh, sometimes they use wire and they are in the shape of a mesh, not just strips, or geotextile fabric. What is geotextile? From the name geo means soil, textile means cloth. So it is as if it is a cloth, قماش in Arabic, that is used for soil. If you put normal cloth in soil, it will be torn and it may disintegrate in few years. But this is a very strong material. It is fabricated and it can last long lifetime in soil. It does not disintegrate easily. So instead of using these strips here, we can just add something called wire mesh or geotextile fabrics. By the way, we are going to see later photos for them. These materials are light, easy to transport, and rapid in construction. You don't need to carry lots of materials. If you want to construct a wall, you need to carry bags of cement. You need to carry reinforcing bars. You need to carry wooden pieces for the forms. You need to carry lots of material. But here you don't need anything except the facing and few strips or few meshes. These and the rest, the major part of the wall, are just the soil from the site or near the site. So you don't need to lots of transportation of material, require limited machinery, nothing. Sometimes if it is small construction, people may by hands can construct this like pieces of Lego. So it is it does not need a lot of effort. Of course, for big walls and big facings, maybe it would need cranes to carry it, but for small walls and small pieces, it is easy to carry. Reinforced soil increases the bearing capacity and eliminates differential settlement. Of course, this is very elastic wall. So it is not possible for this wall to crack or to deform because it can carry any differential settlement from the soil. And finally, when I finish construction, if any settlement happens in between, I can just add more layers on top and I end up having a very leveled surface for this wall. So this additional weight, it increases the bearing capacity of the soil. So the bearing capacity of the soil is increased. The material itself is very good and it's very flexible and it can carry any differential settlement that is expected to happen during construction. And of course, we said that it is rapid, and of course it saves land. Why it saves land? Because the other option is to use a slope. Using a slope, of course, it is slope is also is not expensive, but it will use a lot of land. But here it is just a wall similar to the retaining wall, but it does not cost as much as a retaining wall. This is another shape, but it shows us the parts of this system. We have a small footing at the bottom, just a small footing, and above this footing we put these facing. It may be very like blocks. A normal person can carry this block and put it in place, and they put a row of blocks. Each block is connected to a strip, or the full line of bricks would be connected to what we said before, the reinforcement, the grid reinforcement. Here, let's just go to here. Here we said wire mesh or geotextile fabric. So here I can put strips or wire mesh or geotextile fabric. As I said, we are going to see photos for all of them. Maybe for strips I can connect it any place, but for geotextile fabric and wire mesh, it is better to put it in between the blocks. So at this level I can put my mesh, because it is as if it is a big layer of this wire mesh or fabric. And I have the fill. Another factor you need to know is this SZ. So if I say SZ will be the vertical spacing between the mesh or the strips. And if I say here SY, so it is the horizontal spacing between the facings or the wire mesh. Okay. Okay. So now we go to the next slide. Here we can use this geotextile not only in walls, but I can use it in another way. Suppose I have a soft soil and I need to put an embankment on top of this soil. If I put the embankment on top of this soil, maybe the embankment is a road embankment. I need to construct a road here, and I'm afraid that this road, with time, the soft clay would consolidate, and I end up having something like this. So what can I do to prevent this? I can just add here a layer of this geotextile reinforcement, grid reinforcement, anything that we have just said, we can put it here, and this would help up as if I am putting a reinforcement below this embankment, so it helps up in redistributing the stresses, so that the stress coming to the soft clay would be redistributed on a bigger scale, and the settlement would be reduced. So I can use this, of course, in walls, and I can use it also in embankment. This is just a table for comparison between geotextiles, geogrids, and a combination of both, but I prefer to use these photos to describe what we are going to say. This is the geogrid. As I said, the geogrid are made of special type of plastics. Of course, it's not plastic, but it is geogrid. It is something that it is geosynthetics. Something that are constructed mainly to be used with soil, and it would not disintegrate. So this material, I can use it as, I can construct it to be this triangular shape, square shape, rectangular shape, any shape I need. It is exactly like the wire mesh, the mesh reinforcement of steel, the steel mesh reinforcement that you use in concrete. But instead of being made of steel, it is just made of geosynthetic material. This material is inserted at a special level, and then I put soil on top of it. Soil will penetrate it and will go above it, and I just compact the soil on top. Once I finish, I put another layer of this geogrid, and I put more soil and compact, and so on. Layer of geogrid, soil material, fill material, compaction, and then another layer, and so on. So I end up having all of these layers of mesh. But what I do with this layer of mesh here, once I reach here, this is the mesh here. I put this wire mesh. But once I reach the facing, I connected with the facing. So now, at the start of the construction, I will put this piece, this facing only. And once I put this facing, I put this wire mesh. And then I start adding soil here. All of this is soil. And then I compact. And then I put the other facing. I connect it to another grid and put soil and so on, compact and so on, this and this and this, till I finish my whole, all of what I need. But to be honest, of course, this is a very good system, but it is applicable for new construction. You cannot tell me to use it to support something that is standing now. If you have piles of soil that is in place and you want to construct a wall to prevent them from falling, you cannot use this system, because this system will necessitates that you would remove and put your wall and then backfill again. So this would be additional cost. But this is very good for new constructions. So go again. All of these are new constructions. This is new construction, this is the new construction, this is the new construction. So this is the geogrid. What about the geotextile? The geotextile, they are both they are synthetics, they are made for soil, but one of them is made in the shape of a grid, the other is made in the shape of a cloth, as if it is textile. So it is sheets, very big sheets, and of course it have two types, woven and non-woven. It's not important now, but these geotextile are as if you are bringing very big pieces of textile and you put it on the ground. And then once you put it on the ground, you fill it. Imagine that my cloth is on the surface of the ground. And then I will put here the soil, a layer of soil, just a small layer of soil. Maybe 20 centimeters, 25 centimeter maximum. Once I finish, I wrap this geotextile like this, just like this. And then when I finish this layer, I bring another layer here. This is another layer. I'm going to bring here now another layer, something like this. And once I finish, I wrap it also like this and put my soil inside. And so on, layer by layer, till I finish the wall, something like this. Here another layer and put my soil, and so on, layers on top of each other. Why do we wrap it like this? we wrap it like this because in this case we may not use a facing. This wrapping will do the same task of the facing. I don't need to put a facing here. But sometimes I put a facing for architectural reasons, because as you see, this shape is not very fancy. If I need a fancy wall shapes, something like this wall, then I need to put a facing to for architectural reasons. So this is the geotextile, this is the geogrid, and here a combination. Maybe I would put both. Why would I put both? Because each type of these have a benefit. Geotextiles are connected to each other. They are good in keeping material in place in case I have water coming from one place to the other and I'm afraid that the water would carry if I have water coming here and this water, once it passes here, it would take the fine particles away. So I'm afraid using this grid will not prevent water from carrying the fine particles. But using the geotextile, because the geotextile is like a cloth, it prevents, it just let water passes, keeping the particles in place. So this is a benefit of geotextile. But what about the geogrid? The benefit of geogrid is that it is stronger. It is stiffer and stronger, so it can carry more load. So suppose I need a combination of both, I can put here, this is the geotextile, and I can put geogrid on top of it. So instead of using a layer of geogrid or a layer of geotextile, I put a layer of a combination of both. So in this case, I have both benefits to be used. Reinforced embankment over soft foundations. We said this, how to do this. It's not that important now. I can use it also in reinforcing slopes. So we said that we can use it to reinforce wall, and it is called reinforced earth. And I can use it to reinforce as a reinforcement beneath embankments. Now I can use it also for slope stability. Instead, if you construct a slope like this, this slope is a gentle slope. If I add to this slope to be like this, in this case it is not a gentle slope, it is a steep slope. Maybe due to this I would end up having a failure like this. So what can I do? I can just use reinforcement here. But of course this applies to slopes that are constructed, not existing slopes. So during construction I can put layers of reinforcement here. These are all layers of reinforcement. So this layer will prevent any slope failure that would happen. This is a comparison between the shape, of course for a very shallow depth. This is a comparison between a normal retaining wall. Of course, in shallow depths, if you have a wall 2 meters, 3 meters maximum, both systems are okay. A reinforced steel wall would be okay. This reinforced soil earth would be okay. Why? Because for shallow depths, the cost of reinforced concrete is not very high. The problem starts with having walls more than 4 meters, 5 meters. Here the price increases sharply. In this case, this system will be much better. So just as a comparison, this is a normal wall and this is the soil beneath it. So this is only the wall, and here I have what I am retaining. This is the soil that is retained by the wall. But in this case, this is the facing, these are the strips. All of this system is my wall. So this is the main difference. Now, better photos and presentations. This is the facing. As you see, the facing is similar to hollow blocks that we use it in normal construction. They bring these hollow block pieces, they put it in rows like this, and once they put one row or two, they would add in between this reinforcing grid, and they add the soil, and they put another one row or two, and another row of reinforcement, and put soil and compact, and so on. So we end up having a very big wall like this. Imagine that this wall is carrying a bridge. So it is very cost effective. You are not putting a lot of money and you are carrying very high amounts of loads. So this is, and of course the shape is very good. It is architecturally appealing for anyone, because you are having not the solid shape of the reinforced wall, but it is sometimes it is colored. You might have seen lots of bridges here in Egypt, and they use these bricks for decoration. Sometimes they write something or they draw something. So it is very good in all terms. Some people at the beginning were avoiding this system, saying that we do not guarantee the lifespan of this system. But as you see that this system was proposed in 1963, so it is more than 60 years ago. During this 60 years, the systems that were constructed using, the walls that were constructed using this material was very good and proved to be very good. Some people say that they are affected by ultraviolet. No, now they are UV resistant, so they are very good in terms of rapid construction that is not very expensive at all. So this is how we use it for reinforcing the slopes. I may use wrapping system similar to the one I proposed before. We can put just the material here and wrap it like this, another one here and wrap it like this, and so on, each one, and wrap it like this, and put the soil material in between. I end up, instead of having a wall, I would have a slope going like this, and this slope would be very stable, and I can guarantee it lifetime. Let's see here. The name, slopes may be called reinforced soil slopes. So I may have reinforced soil wall, and I may have reinforced soil slope. I may have a reinforced soil embankment. So the name is in reinforcing the soil. That's all what we need to concentrate about here. There is another name called mechanically stabilized earth wall. It is the same system, mechanically stabilized or reinforced earth. As I said, it depends on the company that is using this method. So don't be affected by lots of names. mechanically stabilized wall, reinforced wall, reinforced earth. All of them are describing the same function and the same behavior. This is a very, very good presentation. These are the facings of the wall. Of course, they are very decorative. So they are the facing panels. These are the reinforcing. It's either strip, so strips. Each strip is connected to a facing, to a part of a facing, or they are either layers of geogrid, geosynthetics, anything, and where these strips end is the end of my wall. So my wall is this square, and this is what I can retain now. I can use the above for carrying buildings, roads, any loads that I need to use. Here, of course, as I said, this is the abutment of a bridge. Abutment of a bridge can carry very high loads and traffic, of course. The same mechanically, this is also a comparison between a wall and another wall, but it is mechanically stabilized earth wall. As I said, the facing of the wall may be just vertical, inclined a little bit, or inclined a lot to be just a slope if I need to have it like this. The upper portion of the wall may if you remember when we studied Rankin's theory, we said that it only carries, if I use it, I can use a horizontal wall, but of course here this system can carry anything. The upper part will be considered, of course, the upper part will not have any reinforcement, but it will be considered as a load on top of my wall, and it will not have a big effect on my wall, not like a reinforced wall, because when I add load on top of my reinforced wall, I am increasing the stability of my wall. So in this case, having an inclined surface is not a very big problem to me, but maybe a benefit. What are the components of my reinforced wall? The skin or the facing element, the reinforcement, and the soil. Here, this is the skin or the or the facing. This is the reinforcing elements and the soil in between. Okay, so now we finished all what we need to know about reinforced earth, reinforced soil, mechanically stabilized soil, anything like this. All of them, we now understand what we need. We'll just go through the coming slides very quickly, because this we will need in case we want to design a wall. Designing of a wall usually this is a know-how system. It means that the contracting company or the company that provides this wall usually makes the design. But if the consultant, the project consultant designs, his design will be as if a guidance only for him to estimate the quantities and the cost of the project. But the main design is done by the contracting company that will construct the wall and guarantee the action of this wall. That's why usually you do not design except if you are working in a company that provides this system. But in normal consulting companies, you just give a rough design, a rough estimate for it. So what are the components of this? We said that the sand. Of course, sand should have quality. I'm not going to bring any sand and use it. This sand should have a quality. One of the most important thing is the fine particles. If you, instead of using sand, you use silt or you use clay. No, you cannot do this. You should use sand with very limited amount of fine particles, maybe less than 10%. So it is similar to the sand that you use it for normal compaction that is used in big projects. So this is about the sand. Of course, if I want better sand, I would bring sand with high value of phi, so that I would have big strength for this sand. This is how usually, if I have a wall like this and I have the soil backfill here, and this is the full system, if I don't have a wall, what will happen? This line will fall. I will find that all of this portion will fall down like this. So actually, when I put my wall, I am preventing this portion from falling. How to prevent it? I need to add, after this line, these are the lines that are preventing my soil from falling. So I need to add more length to the facing. If my facings stopped here, suppose that I am not facing of these lines, just stopped here. I just use these lines. What will happen? Of course, this line will make this as one part, but it will fall. It will fall as one part. Instead of falling as pieces or dumped below my embankment here, it will just fall as one triangular piece. So what I need to increase this to go far beyond, and this to go here, and this to go there, and this to go here, so that I make this portion carried by the standing portion. This is the portion, the active portion that is going to fall, and this is far away from the wall, so it is not going to move. So if I connect both together, then I'm connecting the part that is falling with the part that is standing, and the wall can stand. The skin, as we said, the skin or the reinforcing or the face, this is a very important part, but actually, even if I remove the facing, my wall would be standing with minor collapse. Why? Go to this. Suppose that you removed the facing here. What will happen? Let's take the first layer. For the first layer, I will find that only these small amounts will fall, but the bulk of the reinforcing earth system will stay in place. This will fall. Why? Because the facing that was keeping them in place or was removed. So this small portion followed by this small portion fall, and so on. Just small portions are falling. So the skin is important mainly for architectural reason, because it gives a very good architectural view. But of course it is for structural reasons, it is important for long term, because as a beginning this will fall, but maybe with time I have something like this, and with time I have something like this, and so on, till I find that my wall is changed to be a slope. And in this case, it will be a stable slope. So to prevent this action, I need to use good facing or designed facing blocks so that it would keep my wall in place. Of course, all of these are examples. This is a comparative example in Japan after the Kobe earthquake. This is a wall and this is a building. This is before and this is after the earthquake. The wall stood in place, nothing happened to it, and the building was demolished, shredded into pieces. So why? Because our wall is flexible, but buildings are stiff. So these stiff buildings, once they reach a damaging load, they collapse. But for something that is flexible, it will move with the earthquake and it will return back to place. What about the skin? The skin has, as we said, it has dimensions. It may be square, it may be with architectural pieces just articulated and put in place. So, like you remember the puzzle shape. You may have something like this. But of course not very different, but I mean any shape can be used, but to design them I have to use the exact dimension. Last thing is the reinforcement. Here this is the facing, I'm going to connect this facing to a reinforcement. This is it is either a strip reinforcement or I may use a line reinforcement like this, something like this. All of this is a layer of reinforcement. So whatever I use, as we discussed, this is what we are going to design. So the other thing that we design is the reinforcement. Is it a strip or is it a grid or is it a geotextile layer? Anything I design. This is just a shape to show you how we wrap the soil inside. If I use this reinforcement, but not strips, I use reinforcement geotextile. The geotextile help me in wrapping these systems. Sometimes I use strips, but I add at the facing these outer fronts. It may be, of course, there are lots of details depending on the companies that are using the system. We cannot say that this is available in all companies, but some companies present a special system and they are used to presenting it and developing it and using it in their construction. So it depends what type, what system we are using or what company that we are dealing with. When we come to design, there are two types of stabilities that we need to ensure. There is internal stability, because maybe I would put here the reinforcement that is not enough. Maybe my reinforcement that I put here is not enough, and I finally find my wall going like this. What happened? This reinforcement was not enough. The forces was high, so my reinforcement was either detached or broken, and I end up with having this. So this is internal stability. I need to check the internal stability of the wall. I need also to check the external stability. Maybe my wall is very good, but I end up having something like this. This is failure. So what can I do to prevent this failure? Maybe use longer wall. Maybe I need to extend my wall a little bit like this. instead of having this small wall, I would extend it like this, so it would prevent this slope failure from happening. So I either have internal stability or external stability to study the whole system. These are just shapes of drawings. When we come to study each layer and we need to design each strip, I need to calculate of course I need first to calculate the wall, the load, the horizontal load on the wall, and I take the portion that is carried by each facing, and from here to say the facing is carrying this to this, so I just take from here to there. This is my stress that is affecting this this facing, so I need to design a strip that would carry this amount of load, and I would design this strip. How to design it? Based on the friction between the strip and the soil, and I design the length of the strip. If I put this strip and I found it unsafe, I increase this length a little bit like this, and so on. Usually, I need strips that are longer at the top and smaller at the bottom, in case I am designing the internal stability. But if I am designing the external stability, maybe I would need both the same, or maybe those at the bottom to be longer. So you design internally and externally and put the amount of the length of the reinforcement that you need in your wall. This ends up our lecture for this reinforced earth system. This ends up also all what we need to speak about horizontal loading of soil or horizontal pressure of soil. Walls and shoring, retaining walls, shoring systems, reinforced earth. These are the three most important systems for that would carry horizontal loading on soil. Thank you, and see you next lecture.